Okay, that's the plug I made. It's 120 volts into right here. Now I have really four components to this. I have a 24 volt to 100, I'm sorry, a 120 volt to a 24 volt transformer. I have a 24 volt relay switch that can switch 120 volts. I have just a plain old digital thermostat. This is a non-programmable one. I don't need one. And then there's the bathroom fan. What happens is this transformer runs power to the relay switch. The relay switch runs into the thermostat, and the thermostat runs back to the transformer. And the thermostat is actually switching based on the temperature. It's basically like a thermal switch. And when it switches on, it sends power through this relay switch, which then makes the 120 volt connection. Now I only have one wire running from the relay switch. Well, I have power running from, I have 120 in to the relay switch, and then 120 out from the relay switch to the fan, and then I have 120 out of the fan back to my wall outlet over there. So the way this works is, right now room temp is at 73 degrees, and the thermostat's set to cool. The fan's not running right now, but if I set the thermostat below room temperature, it turns on. And when I set the thermostat back above room temperature, it turns back off. These thermostats are built with delay switches because they can't, an air conditioner can't tolerate an on and off, on and off, on and off within a short period of time. So these thermostats are built with delay switches. So if I were to say set this back down below room temp, it's going to be about 3 minutes before that comes back on. But that's really no problem as far as my use is concerned. So it doesn't really even bother me that much. But yeah, so that's my thermostat controlled power switch, or bathroom exhaust fan.